So, how do we use the definition of the limit to calculate the limit? Well, to be honest, the definition of the limit is not the most useful way to calculate limits, but it is the rigorous way of doing it. I will give an example, but I do recommend people to not stick to the definition of the limit. It is a very time consuming type of calculation, which you shouldn't do for every example because it is very common to find lists of exercises which have more than 100 limit exercises. So having the less rigorous approach more handy in your mind is a little bit better before we go for more variables. But for one variable, we will use this following example. Let's say f of x is 2 times x squared minus 1 divided by x minus 1 for x different than 1. And we can express this the following way: 2 times x minus 1 times x plus 1 divided by x minus 1. This function is not defined by x equals 1. So if we want to have x different than 1, this is the same as canceling both of these terms here, and we get 2 times x plus 1, which is 2x plus 2. And if we go for x going to 1, the limit of this function is going to be 4. I am affirming this. I didn't prove this yet. Let's say f is different than 1. So let's see what happens if f is different than 1. If it is different than 1, we can use this definition. And if we can use this definition, we can make things in this form appear the following manner. We will take the absolute value of this. So this is 2x plus 2 for x different than 1 minus 4. So we are doing this f of x minus L in the absolute value. We know that this is 2x minus 2, only doing the manipulation inside here. And we know these 2 can go outside and go and leave us with 2 times x minus 1. Let us say that we have an epsilon that's bigger than 0, and let's say delta is epsilon divided by 2. This means that we are going to arrange things in this following manner. This will mean that delta is bigger than x minus 1, which is bigger than 0, which implies that epsilon divided by 2, which is equal to delta, is bigger than x minus 1, which is bigger than 0, which means that epsilon is bigger than 2 times x minus 1, which is bigger than 0, and epsilon is equal to 2 delta, which means that f of x minus 4 is smaller than 2 delta, which is equal epsilon, and we have this exact structure. So this proves that for the choice delta equal to epsilon divided by 2, the limit of x to 1 of 2 times x squared minus 1 divided by x minus 1, this limit is 4. But in practice, we rarely need to do the rigorous proof. This is just the rigorous proof of what the limit is by the definition, by using the definition. But we don't usually need to do that. And I'll give an example of what to do more usually, and then I'll talk about properties of limits.